What if I told you there's a single equation that could actually measure an AI's intelligence? But here's the twist. What if that very same equation also revealed a dangerous, hidden limit to just how smart AIs can get? Well, today, we're going to dive right into something called the Aether Equation.
Okay, so we're going to start with this image. Now, at first glance, it just looks like some cool piece of abstract art, right? But according to the paper we're exploring today, this is a literal picture of an AI's mind at work. It's like a map of its potential. And trust me, it holds a secret that is both beautiful and, honestly, pretty unsettling. So here's the fundamental problem, right? We have all these AIs that can trade stocks, they can write code, they can do a million other things, but how do we actually know how smart they are? I mean, you can't just give them an IQ test. What we really need is some kind of single, meaningful number, something that tells us for sure if an AI is genuinely pulling real signal from the world or if it's just, adding to all the noise. And that is exactly where the Aether Equation comes into play. Researchers have come up with this three-part metric to do just that. The goal is to put a single score on an AI's effective intelligence to finally tell us if it's genuinely smart or if it's just faking it. The equation itself is actually pretty simple, which is what I love about it. It's basically built on three pillars. So first up, you've got observation space. Think of it as how much information can the AI actually see? How many different sources can it process? Second, you've got accuracy. That one's pretty straightforward, right? How often does it get things right? And third, this is the one I find fascinating. Humility. It actually penalizes an AI for being too much of a renegade, for straying way too far from what everyone else thinks. And this quote really just sums up the whole philosophy perfectly. Think about it. You could be 100% accurate, but if you're only looking at one tiny piece of information, well, you're not really that smart, are you? Or you could see everything, but if you're always wrong, you're just creating chaos. And you could be an absolute genius, but if you're so arrogant that you just ignore what everyone else is saying, your effective intelligence actually goes down. So it's a really cool idea, right? A really elegant concept, but it brings up the big question, does this thing actually work in the real world? Can you really take this philosophical equation and apply it to actual AIs doing their thing out in the wild? Well, to find out, that's exactly what the researchers did. They tested it on two completely different AIs. First, there was an agent named Ocho, which plays in the super chaotic world of live prediction markets. And then there was Multi, an agent whose whole job is to improve its own computer code all by itself. I mean, two totally different playgrounds. And the results? Yeah, they were pretty striking. Ocho, the one trading in the markets, it clocked in with an Aether score of plus 6.94. And that positive score is the whole key here. It means the AI is actually finding real signal in all that market noise. It's creating real value. Okay, but then they tested Multi, the agent that improves its own code. And wow, its score was even higher, a plus 36.61. So it was also extracting real signal, just in a completely different world. It looked like the equation was working no matter what the job was. And this is what really shows how portable this equation is. I mean, look at this. You've got Ocho with 5 inputs, gets a pretty solid accuracy score. Then you have Multi with 6 inputs and even higher accuracy, which leads to that huge Aether score. So what's the big takeaway here? It's that the same exact ruler was able to measure two totally different kinds of intelligence, and it gave a meaningful result for both of them. But this is where the story takes a really interesting turn, because it turns out that final score, that single number, that isn't even the most important part of this discovery. The equation was hiding something else, something visual. Remember that image we started with? Well, it turns out that when you run the Aether equation over and over again, it doesn't just spit out a number. It generates these incredible fractal images. And the researchers had this amazing realization. This isn't just some pretty side effect. It is, quite literally, a map of the AI's entire mind. Okay, so here's how you read this map. See that dark black area? That's the stable zone. That's the good place. It's where the AI is effective, where its thinking leads to a sensible answer. Now, all those colored areas, that's chaos. That's where the AI becomes unstable, its calculations just spiral out of control, and, well, it basically goes insane. You definitely want your AI operating in the dark part of this map.
And this is where we get to the really startling discovery. That map, that safe zone of stable thinking, it isn't fixed. It actually changes depending on how complex the AI gets, specifically on how many inputs it's trying to juggle at once.
Just look at this. This visualizes the central warning of this whole paper. On the left, you've got an AI with just 2 inputs. Look at that massive, dark, stable zone. It has tons of room to work safely. But now look at the right. This is an AI with 11 inputs. And that safe area, it's almost completely gone. It's collapsed into this tiny, fragile little island, surrounded by a sea of pure chaos.
And here's the thing, this isn't some gradual decline. The research points to a sharp phase transition. It's like hitting a tipping point. Right around 5 inputs, the system just hits a wall. That stable window doesn't just shrink, it collapses. Get this, the paper calculates that going from just 4 inputs to 5, adding just one more piece of information, wipes out over 96% of the safe zone. It's just gone.
And this all leads to a really chilling and frankly counterintuitive paradox. The paper calls it the fragility of excellence. And what it means is pretty simple. In this model of intelligence, being smarter also means being more fragile.
You can see it right here in the data from Ocho, the trading agent. As the researchers actually made it smarter, as they improved its accuracy, what they call its Breyer skill score, its safety margin, its buffer from that chaos zone, was cut in half. So yeah, it got better at its job, but by doing so, it was flying closer and closer to the sun.
So let's just break down why this is so important. This suggests that just making AIs bigger and feeding them more data, just scaling them up, isn't some guaranteed path to success. In fact, it's the opposite. The most capable, the best performing AIs are, by the very geometry of how they think, the ones living right on the edge of that cliff of total failure. The best ones are, by definition, the most fragile.
And all of this leaves us with a really provocative and I think vital question. As we race to build ever smarter, more complex, more powerful AI, are we accidentally engineering their own fragility right into them? Are we pushing them, and by extension ourselves, closer and closer to some invisible edge?